Hello, good morning if you're in Australia, and hello wherever you are if you're not. So, last night I streamed trying to finish off the rest of the rounded corners we have left up, but we don't have any others. And it was a complete disaster. If you're watching this on YouTube, you're probably not going to see last night's stream. I don't think I'm going to upload it because I achieved exactly nothing. However, thanks to the generosity of Scott, who wrote the code we have for one track, last night this PR came in, which ignore all these warnings. If I scroll down here, basically what he has done, because this is what I was struggling with, is changed our move left up method to just extract things to other methods. So we have a move counterclockwise, we have a move clockwise, there's rad to degree and degree to rad to help, etc. But this is super helpful because I was struggling to change these things and having them. So when Scott was writing this, because all of this code was written on stream, and I followed along, and I could understand what was happening, but what I didn't grasp was the bigger picture. So when writing this code, I was thinking, oh, well, this needs to change, I was tweaking this, whatever. Having it now in a method called move counterclockwise, I now know, essentially I'm an API consumer of this, so I now know I can trust this code, this moves counterclockwise. If that's what I want to do, then this code should do it. Obviously, tests and unit tests and whatever would be good, but let's go with faith. So what it means is that when I'm making the other corners, I now have a few more tools in my tool belt. As what I was working with before was all of this math stuff, and I'm just not good at math. I tried to avoid it as much as I can, and it's clearly paying dividends now. But so let's merge this pull request and see if we can't go from here to actually get some stuff working. And in fact, where I got up to last night, the end of last night, let's see if this is finished yet. So where I got up to at the end of last night, which again, you won't see, is I worked out that the problem was I wasn't thinking about where in a circle we are. So let's just run. I've done that and I'll show you what I mean. So, if I draw a circle on here, if I draw a circle on here, that's not a circle. If I draw a circle on here, cool. So, I'm just going to mark, and let's draw a couple of lines. Let's go a line like this, and a line like this. Okay, so this is 0, 0 in our coordinate system, and I'm just going to call this 100, 0 and 0, 100. This is the coordinate system that we draw tracks, trains, everything in. Positive numbers is going down, Y is vertical, X is horizontal. The track we did with Scott a week and a half ago was this shape, left up. So connected at the top and connected on the left. And so you can see that all of the numbers, all of the positions here would all be positive. Right? If you take this 0, 0, let's pretend this is 0, 0, all these numbers would be positive. My problem last night is I was trying to do this segment of the track right up. But if you take 0, 0 here, which is where the origin of our circle is, all of these numbers, this left area, is negative. And I was not taking that into account at all. So what I ended up with was just dodgy math. I'll see if I can show you what I mean by that with this new code. there we are. So if we find our new move left, oh, I need to get the latest changes. That does not look right. So I'm going to do the same thing I did before. Here we are, lovely, lovely methods. So let's copy move left up. Same thing I did last night, and we'll make it move right up. And we'll put that in here. So hook it up. Okay. So now that we can read this, so we convert our current left and top into an angle. So this left comes in at 0.5 and this top comes in at 0.1. So if this is 0, 0, let me get another color here. If this is 0, 0, here's our origin. We're coming in on our track. Our train is coming in here. Right? Pretend this is our track. But left is 0.5. Well, this is not 0.5. This is negative 0.5. Right? This is negative. And that's the problem. Top is 0.1. That's fine. This is still positive direction going down, but the left is negative. And so what I was doing, essentially, without changing those signs, is I'm trying to calculate the angle for something that looks like that, where I'm in this quadrant, but I expect it to go in that arc. And obviously that's not going to work. The maths that we have here is not for that angle. So the first thing I did wrong and that I need to do here is I need to offset this relative left. And what I was doing last night was 1.0 minus, I was doing 1.0 minus relative left. That makes no sense. Essentially, well, it kind of makes sense. Okay, so this is 0.5, this is 1. So I was calculating this distance. Obviously, that's not what we want. What we want to do is minus 1.0 minus this, so we get this distance. This is the distance we want to calculate. Now, the easy way to do that is to simply minus 1 from that. So if we're here, we minus 1, we're over here. Make sense? Maybe? Well, yeah, sorry. If we're here, because we start on the, we'll go this way. All right, remember, we're conceptually doing this, because this is what gets drawn. So all of this is just offsetting by minus 1. So that's what we need to do. We simply minus 1 from our relative left. Now we need to fix it back, right? So for the context of this method, we're over in this half of the circle, this quarter of the circle, but our relative left and top coordinates in general need to stay the same. So we add back on our plus 1. Then we get our angle to move, that's the same. Now our train angle, I did this last night as well, and I think I did this right. I can't remember what it is, I'm going to have to work it out again. So we need to know if we're moving clockwise or counterclockwise. And here's where these method names make so much sense. Because look, this is the counterclockwise case. I don't have to work it out. So counterclockwise would actually be not this arrow. It would be coming in here. And so when we come in here, our angle is going to be 180, I believe. Because if you can imagine us coming in this circle, right, here's our 0, so we're actually over here, so we're coming in this way. So I believe we're at 180. So that essentially means, now hang on, maybe I'm wrong about that. 180. So that is coming in at 90. It could be 0, it could be 180, actually. Alright, let's think about this. So we're doing a track that in general goes in this direction. And so any angle on this side of that line Hello. So OBS crashed. Sure, fun. I'm not sure how much you heard of that, so we'll start again. Kind of. What I'm trying to work out is, what is the angle of the train going to be when we're moving counterclockwise? So we're on this path, so we're moving this way. So our angle is going to be essentially between, we're going to start at 180 and we're going to end up at 360. So any of those angles, we're moving counterclockwise. We want to continue to move counterclockwise. Now, we don't know if it's exactly 180 though. So I'm just going to say if it's greater than 135. I think that's right. And if we're coming vertically, we're coming down here, that's 90, we're going to 0. I'm pretty sure that's right. But I definitely could be wrong about that, because that's not what I had last night. I think last night I had greater than 45 and less than... Oh, that's right. So this horizontal line... Oh, that's right. That's what I did. Essentially, I took these two coordinates here and said, right, well, if we're in this arc, we're going counterclockwise. Okay. Yeah, that makes sense. So if we're greater than 45 and is less than 225, then we're going counterclockwise, and we need to specify this minimum angle. So we're facing right up. Well, that's not true. We're facing right. Oh. We are. Wait. Does that mean these comments are wrong? Relative left? Oh, maybe not. No, the track is right up. So this way we're facing left and up. So we move counterclockwise. Now our minimum angle. So we're going this way. A minimum angle here would be 360, but that's a maximum angle. That's odd. I wonder if this angle is going to come out negative as well, because my left is negative. Let's see. Let's do the clockwise. So clockwise, we're going from 180 to 0. Oh, sorry, 90 to 0. So this is 0. Move clockwise. So if we get above 0, now see, that seems wrong as well. Alright, let's just see what these numbers come out to. Trial and error is much more fun. Or at least kind of works, hopefully. And hopefully OBS doesn't crash on me again. And hopefully the stream is working. Hello, good morning. I'm going to assume that since you said morning, you know that I'm here, and therefore the stream is working. But you may be joined after OBS crashed. Alright, so machine is warmed up. So we want a right up track, which is this way. And let's approach from the top. So our angle is 90. So we should be going counterclockwise here, which is correct. So let's have a look. Our current angle is pi, a bit less than pi. That makes sense. So a bit less than pi, that's 180, that's here on the circle, so we're coming in this way. That makes sense. Ah, I see. So our minimum new angle. Okay, so this is where it gets super confusing, is the two angles in play. One is the train angle, which is 90, which means the train is straight up and down. But then the other angle is if we have a train and we draw a line from the train to the middle of the circle, it's this angle or this angle. Not easily. Let's give it a colour. So, plus it's not centered. So this angle, bear with me. I'm erasing. So this angle, the blue line here, is our other angle. So we have our angle here, which is the angle of the train, which is starting at 90. Then we have our blue angle, which is currently at just under 180, which makes sense. So the minimum angle is actually 90, because we're going down to here. It's not the minimum angle for the train. Okay, I think I need to start renaming some of these too. So current angle. So if that's train angle, what is current angle? I don't need a new name for that. Is that a chord? No, a chord is a part of an arc. Anyway, so this is going to be math.pi divided by 2. The other thing that's annoying me is that some of these are in radians and some are in degrees, but maybe that's a good thing. Actually, if we can keep all the train angles in degrees and the other angles in radians, maybe that's a good way to separate them. So I'm going to leave this and I'm going to assume this is right. Now, okay, back to our clockwise thing then. This is obviously wrong because it's not going to be the same as this. So our maximum angle. So if we're down here, our train angle is 0, which means our blue angle, what do you call blue angle, is 90. So we're going up this way and our maximum is therefore 180. So it's math.pi. And that's 180 and we're facing left. I thought I changed. Oh no, this is the left up method. Okay, is this the right up? Okay, so this should be 180, which is math.pi, and this is 90, which is math.pi divided by 2. We are not facing left or up. Okay, let's see if this works. So this is right up. So we have a right up track. Hey, ooh. Okay, that's interesting. Let's see if it works the other way. Okay. That makes me think this might be wrong. So let's debug it. I'm really tempted to change all of these to degrees as well, just to... The debugging is kind of annoying when you're inspecting this current angle and it's like 0.000 whatever, trying to work out what that means. So, okay, let's first of all we'll fix up these things. So train angle. So we're at 90, that's cool. Our current angle is just over pi. I would expect this to go down. And in there. So this should go down. Oh, I missed that. I think I did. A little bit. Very small amount though. So our train angle is now 89, that's right. And our relative top is... That should... Oh no, we haven't changed relative left. Sorry, relative left would have been negative to work out the angle. We haven't made, no, that's right. So it's moving slowly to the right, which is correct, and it's moving slowly down. That's correct. So 3.135 is now 3.03. That's good. Okay, this is looking good. I kind of need this breakpoint to be here. Don't know. Okay, so 72. 1 minus relative left. See, I had that last night and I think that was wrong. But maybe... Anyway, let's see what's going on. 72, 66. Oh, our angle is going to get to be less than 45. That's what's wrong. So our angle now is 49. We're going in the right direction. Now we're 43. We're underneath. Oh, wait, hang on. Yeah, that's the problem. So now we're turning around here. So our train angle, maybe it is just less than 90. Yeah, okay, maybe that makes sense. I thought I had this last night correct, but let's just try it. Less than or equal to 90. We want to move counterclockwise, which makes sense. 90 is pointing down. The whole arc we want to keep going down. Hey, it worked. And if we go the other way, smooth track, smooth track. Ah, see, I spent 2 hours last night and didn't get that. So the key is minusing 1 and then actually understanding what these are. I am kind of tempted, though, still to turn these to degrees. I don't know if that's a good idea or not. That's alright. Math, in theory, these should always just be 90 degrees apart. And, yeah, that's okay. I can do that math in my head, just. Alright. I will clean up all the rest of this, though. I don't like... I think this tuple return here is a bit long. I'm not used to looking this far on the right to find out what method I'm in. So I'll probably at least extract these 3 into a class. Because this is the position of the train. Alright, so let's do some more. Should we get ambitious and do 2? Why not? So we have right down, and we have, I believe the other one was left down. Yeah, cool. So all these ups become downs. Alright, left down. So left down is this arc, so our y is now moving in the negative direction, but our left is still positive. So, whoops. So this goes over here. Once Visual Studio is happy with me dragging code. There we are. And likewise, this goes over here. Okay, so train angle. Our train angle now will be, if we're going counterclockwise, that would be the scenario when we're coming up. So our train angle is going to be 360, and then we're going to lower it to 270. Pointing that way. Sorry, wait. Oh, that's... yeah, that's right. No, wait. What's up? No, up is 270. We're going to lower it to 180. I think. I'm not sure, but I'm just going to debug all of these because this is trying to work out this stuff. I don't know, it does my head in. So if our train angle is 270, sorry, no, our train angle at that point is going to be 0, and our minimum, no, our minimum now would actually be 360. We'd be going negative. That's interesting. So this would be negative negative 90, I believe. Let's see what that looks like. And then if we're going clockwise, we're coming in here, so we're at 360. We're increasing to more than 360, but do we fix that? Or are we negative here and coming into 0? Again, I'm not sure. Let's find out. So this was left down. Doing one at a time seems like the easy approach. Understanding math is definitely the harder approach, so I'm glad I'm avoiding it. So left down, and we come in, so this is the clockwise case. Okay, so our train angle, is 0. Okay, so that's too broad, that's cool. So it's less than 270 and greater than 90. And yeah, in fact, oh wow, that's so weird with the ligatures. In fact, let's make this greater than 45. And this is 225, I think. So 225 is over here, and yeah, 45. Yeah, I need maybe a better way of expressing this so it's not confusing every time I look at it too would be good. So this was, oops, which one are we doing? Left down. Oh wait, did I draw the wrong curve? That's down. No, maybe not. Okay, so we should go counterclockwise. That's correct. So our current angle. Yes, our current angle is negative. Aha. And it's negative pi on 2. Yeah, definitely less magic numbers is a good idea. So it's negative pi on 2, so we should be increasing it to 0. I think that makes sense. Let's see if this math handles negative numbers. So this should go up, which I think it did a bit. Train angle is 0. Go up. Okay, that looks okay. Oh, clearly not. Okay, we got the halfway problem again, which is this thing. Okay, so we're 0, we're going up. Okay, so we're coming in here, so our train angle is 0, and we're increasing to 90. Alright, so this is completely wrong. So when we're coming up, it must be 270, decreasing to 180. Oh, that's 270. Yeah, a better way to express this. Like if there's some way to express, hey, which corner of the thing you expect to be. So I believe the train angle should be 270 going down to 180. So let's try that. I think it would also, I'm kind of afraid of the floating precision of these things. But I think if we can snap some of these things at the end, maybe we might avoid that, and maybe I don't need to worry. That looks better, and then trying to get every direction hooked up is interesting. That's right. Hey. All right, this is looking good. All right, let me check these things. My if triangles. So if we're less than 90, let's just be explicit about this, shall we? Well, that's interesting. Move right down. Oh, right, we haven't done right down yet. Okay, I can ignore that one. So between 0 and 90 yeah, see this one, between 45 and 225. That's what's weird. Okay, so left up. That's between, now this is train angle, so train angle will be vertically down, so that's 90 and 180. So it's greater than or equal to, no, that's going clockwise though. We want to go the other way, which is 0 and 270. Oh, actually, so is that not a, it must be 0 and negative 90, I guess. I'll put a breakpoint there too. Okay, let's do right down before we forget. Okay, so right down, which is this one. So now both left and top are in negative direction. So we need to minus off one here and add it back on here. Ignore this. Ignore this. This is wrong. So are we moving? So when we're moving counterclockwise, our train is coming in at 180, ending up at 90. So 90 and 180. Our minimum angle here is when we end up here. This is 180. But it would be negative 180, I think. Also, I've just realised that what I said here was wrong. Oh no, 189, no, that's right. Okay, and then if we're moving clockwise, we're going up, that's 270, that's 360. Because we're going this way, we'll end up here. That feels weird because it's not a 90-degree difference, but it is logically, I think. I think that's right. Scott says, so it should be plus minus 180 from the middle train angle. Yeah, that's what I was doing originally. That's what I get that, but it's really hard to reason about, so that's why I didn't do it. But yes, you're right, it should be. It should be, yeah. I'm kind of thinking maybe if I can refactor that, some of these magic, because all these are basically the same. If I can refactor these into one method that does it all, then if there's some way to express, essentially here I'm expressing, so these two numbers express the bounds of the train, or of that relative angle anyway. And then this one is, yeah, related to that middle angle. So we should be able to work it all out. Let's just try going clockwise. See if these all work. So far so good. Okay, and then anti-clockwise. Yes, I think it works. That's good, and that is awesome. That's all 4 types, right? That's all of the code, I think, covered. I don't know why that looks too simple, but that was, why was that so easy? Let's do a more complicated thingy. Except for those two. And put it around there and put it around there. Oh, okay, so there's a problem. Whoop, there's a problem. Okay, so what am I missing in my little loop here? Oh, so this is a transition. I bet you this is it's exactly this. Because these are floating point numbers, I think this is where the 45 becomes really important. So here, a straight transition to an angle works great, but two corners transition to each other, if they're not quite, if that's 90.00001, it's going to fall into this case, which then, puts it back to the next cell, puts it back to this cell. Yeah. All right. That's cool. I am shocked and amazed. All right, so let's fix up these train angle things. So 180 and 270 means that our middle angle is 225. And so essentially we want 225 minus 90 and 225 plus 90. That makes sense. So if train angle minus 225 is less than 90, does that make sense? I guess the absolute value of that. No, I shouldn't do this. I'm just introducing mystery here, and I'm not going to understand this in a week. Let's fix it properly. So 225 minus 90, so that's greater than 135, I think. Alright, hang on, where's your handy diagram? Here we are. Yeah, 135 and 315. Whoops. Less than 315. I really wish I had save tracks, because I just drew it all out and now I've got to do it again. Okay, that static place with 8 directions to help. 8 directions, so north, south, east, then northwest, northeast. Does that help? The problem is, I'm not, this, to me, reading this, train angle is greater than 135 doesn't make sense. But reading train angle greater than southwest, I don't think that makes sense either. I don't actually know how to express this. I kind of would like to not express this. Okay, hang on, so wait. What are we saying? This is left down. That's this one. So what we're saying is this moves in an arc from 270 to 360. Except that the 270 here is minus 90, and the 360 is 0, is negative. So we need to express that somehow too. Unless I just normalize this and make this angle positive after we've converted it. And then from there, if we pass in these two, we should be able to work out the train angle. Let's see if I got this right. For left down. So left down is that. That works. And then okay, so that works. So I haven't broken anything. Need a method to say in between these 2 points that can also reason about the fact that 45 less than x. Yes, it can reason about that going both ways, and also reason about minus 270 to 0. But if your angle is, whatever. I think that's what I need. Let's just quickly do this. So greater than, so what I said here was inclusively between 90 and 180. So what I mean is greater than 45 and less than 225. I think. And here we have between 0 and 90, which is here and here. So that means less than 135 which is interesting. So with the 0, I guess what we're doing is greater than -45, but I'm not sure that input, like that probably never could be negative, I don't think. That might be redundant, but probably better to leave it just in case. This one I've done. Alright, is that all? 1, 2, 3, 4. Okay, let's try my funky track again with some interesting transitions without any equal sign. So that we know worked. I don't know exactly how I did the funky transitions, but I'll just try and draw some new tracks. Haven't done any of those sort of dealios yet. Okay, so put a train there, put a train there, put a train there, and put a train there. All of these should, in theory, just keep moving smoothly through the whole system. Oh, this is very cool. This is very cool. We have smooth trains. I am very happy. See, because now I can commit this code and I can never have to think of math ever again. And that's all I want. Is it so much to ask? To just not have to do trigonometry? Draw all 4 corners 4-leaf clover. Yes, that'll work. I don't have a way to... Oh, I can sort of increase the size. Okay, all 4 corners 4-leaf clover. So that's... wait, let me get this. So that's that way, like that, like that. Oh, we haven't done cross yet, though. Is this what you meant? Because, yeah, we haven't done a cross track yet. Unfortunately. What happens if I put a train in here? Does it work? It does. Yay! Nothing but corners. A compact one that's not weird, but doesn't... Don't I have to have 3-way tracks for that? Or just fight with my tractor encode? Yeah, see, I haven't done 3-way tracks yet either. Okay, what if I erase that? Nope. That with 2 down. I need to get collaborative editing because that's what you meant. Clearly, I have never seen a 4-way clever. What? Dash X X X X X X X. So that. I think is what you meant, and I think you mean this, and then hopefully. Oh, that. Is that what you meant? Anyway, I'm pretty sure this all works. Really, that's a 4-way. I guess that is a 4-way 4-leaf clover. Anyway, awesome. I think I'm gonna check this code in before everything starts to break, because at the moment this is all working, and I am absolutely flabbergasted that it is. Look at those little ants marching around. Brilliant. Alright. Thank you once again, Scott, for your expertise in this area. I'm not going to say that I understand this code, because that would be a step too far. But hopefully I can maybe reason about it later, and maybe we'll do some refactoring. What's the time? It's lunchtime. Yeah, I think refactoring will have to wait for another day, but I am so happy that we have smooth corners, and other than the fact that this track class is now ridiculous, just no one should look at it. Should we see if we can quickly do a move cross? I need to go in like 10 minutes, but let's find out. Because a move cross, in theory, so let's go to here. A move cross should be work out the angle we're coming in, and then pass off to either move horizontal or vertical. So, if the angle, and this, well, let's see, we've got vertical train. So here we essentially want, so if it's between 45, whoop, if the angle is between 45 and I can't type, and less than 135, then we're coming in from the bottom, and we should just be able to go turn, move vertical, relative left, relative top, angle, distance. And then otherwise, we're moving horizontally. And here we also need to allow for angles between 215 and 315. It's not 215, it's 225. I think that makes sense. Now I can draw a proper four-leaf clover and we'll see. So, actually, let's do it the simple way for now. Yep. Okay. So, now we can draw the full-on four-leaf clover. Maybe. Who wrote this tractor and code? Join up! I've forgotten how to do it. Do I need more vertical space? Is that the problem? There we are. We can put a train here and here. Oh, it's brilliant. It's a thing of beauty. And there and there. More trains! That is gold, Jerry. Gold. I love it. We are finally at the point where instead of doing any work at all, I can just sit here and draw trains and do nothing else with my life. And I mean, that's all I've ever wanted. Living the dream. See, it's just therapeutic. If you're sick of work, just take a moment, bring up the Trains app, draw some tracks, and watch things go around. But yeah, so this is great. So obviously next steps here is, collision detection, we can do this in track detection, all that sort of stuff. We can never touch any of the math code ever again. Brilliant. We do need to do some more work though. So there's still some more directions to go. And the problem with these ones, or the interesting thing with these ones, this is similar to cross, these three-way ones, in that they just hand off to one of these methods, but they have to know when to hand off. So sometimes we'll hand off, so left, up, down needs to either hand off to left, up or left, down. And it needs to know when to do that. And it gets interesting because when you're coming up, we should follow the track with the planks on it. And when you're coming in from the sides, there's only one, there's no choices. But it maybe gets interesting, maybe we have a switch and we can choose, that sort of thing. But I'm going to leave that for another day. And I'm going to end that stream now. I haven't used degree to rad. I'm kind of tempted to change these to be. This is the only place that I'm specifying an angle in radians. Kind of tempting to just change that. And then I can use degree to rad and... But yeah, I'm going to leave the cleanup for another day. I have 3 warnings though. Oh, that's... Okay. I think we can get to that. Yeah, degree to rad is not used. Alright, I'm going to leave the rest of the cleanup till later. I'm going to delete this because this was the work I did last night that no one shall see. If you weren't one of the 3 people watching on Twitch, you will never see it. And if you're watching this on YouTube, Everything worked great. Smooth always very well. Yay! Thank you for all of your help, Scott, as usual. Thank you for watching, anyone who watched. Thank you for watching if you're watching on YouTube. Go and maybe play with it. I kind of feel like it's... Other than, like, three-way tracks still need to be done, and they're really easy to accidentally draw, but it feels like it's really close to actually being something that someone can pick up, run, and just muck around with. It doesn't do anything yet, but it's a lot of fun doing this. So yeah, thanks for watching, and catch you maybe sooner than you think. There might be some more time to stream this week than previous weeks, so we'll see. Catch you.